Hi everyone, welcome back to day 2 of Principles of Microeconomics. Today we're going to follow up where we left off last class and go through chapter 2. Where did we leave off last class? We left off with the definition of economics, which is the study of how society manages its scarce resources. So economists need to come up with some way to understand how things get allocated to different people. This is actually really hard to do. The reason it's hard to do, for one, is that the world is quite complicated and there's a lot of details, so understanding how one gear turns another is not a trivial task. And then the other reason it's complicated is because the reality is we don't observe everything in the world. So there are truths about the universe that are really at play and they're really true, but we don't always see them. So when we're trying to figure out how one gear makes something else turn, we have to be humble enough to say, there are dynamics at play that we cannot see with our eyes to kind of understand what's going on. So what we're going to do is we're going to have a 3-step process for how we do economics, and this provides us with kind of a helpful framework for understanding how this is functionally performed. So what we do, first of all, is we, as economists, observe. Okay, what does this mean? This simply means that we take the things in the world that are actually seeable and we just pause and we pay attention to them and we say, I see that these different things are functioning in the world and that these gears are turning and these things are happening. If you're familiar at all with economic research, a lot of economists use big data sets. Big data sets are effectively just a compilation of observations. So, for example, I do work in health economics, and so the data sets that I use include a whole bunch of observations from hospitalizations. So I'll see in my data that a patient was male. I will see that they were 25 years old. I will see what their principal diagnosis was. I will see the license number of their physician. And the data set just has all the observable features about the hospitalization built into it, and then it does this for every single hospital patient. So this is the first job of the economist. They have to take what's seeable and they have to kind of ingest it. The second thing is, based on what's observed, we build a roadmap, which in econ language is a model. Okay, the roadmap analogy is a lot more helpful for me to kind of understand this. The idea of a roadmap is, a roadmap helps you do something that would otherwise be difficult so that it's easier. So, for example, suppose I want to travel to Oklahoma City. If I don't have some kind of aid, it's pretty difficult for me to just start out from my sunroom and start getting to Oklahoma City. So a roadmap is an aid that takes realities about the world and it decides which realities are important. It includes the important realities, and it strips out the non-important realities in terms of completing the task. So, in other words, on a roadmap, there are highways. On a roadmap, there are not stop signs, which are a reality of the world. Every blade of grass does not show up on a roadmap. Those are true things about the world, but they're not important for me to understand how to get to my destination. Okay, models effectively are trying to mimic the same sort of thing. A model is what an economist uses to try to figure out something in the world, but the world is super complicated and it's got lots of details. So after making the observation of all the details in the world, an economist has to decide, what are the important things here? What are the highways? And then they take those important things in the world, they include them in the model, and then everything that is not deemed to be important, the true realities of the world that are there, but aren't necessarily important for our understanding of a particular thing, are intentionally left out of the model. Because if we included all the realities of the world, then the model would just get so complicated that it would be no more easy to use a model than it would be to just look out your window and try to observe the world and figure out what's going on. Okay, the last thing economists do after they have the roadmap is we make assumptions. Okay, assumptions are nice because once you make them, you can take your roadmap and you can learn things about the world that you can't see with your eyes. So I'm going to show you what I mean here. Suppose you decide to really embrace this whole econ thing and be an economist, and you decide to go out and just observe the world one day. So maybe you walk outside and you observe that on some intersection, there's two sets of kids selling lemonade. So maybe at the first stand, there's a wooden table with some cute kids behind it, and they're selling their lemonade for $1 a cup. And then the other table is plastic, and there's some cute kids behind it, and they're selling their lemonade for $2 a cup. And this kid has a ball cap on, this kid's got pigtails, and you're really observing. And then you decide, you know what, I'm really gonna observe. And so you set out a lawn chair and you just watch what happens for the rest of the afternoon. Well, maybe throughout the course of the afternoon, there are 3 customers that come up to this stand, and there's 1 customer that comes up to this stand. And then at some point, you get tired and you decide, I'm done doing econ, you go home. Okay, if you got your spirits up the next day and you decide you want to go ahead and build a roadmap, then what you have to do is you have to take what you've observed and decide what is important about that scene and what is not important about that scene. Well, your thinking might go something like this. You might say, I bet the reason this kid got 3 customers is because his lemonade's cheaper. If that's true, then what's important here? The price is important. The ball cap and the pigtails, that's not really important. The wood and the plastic tables, that's not really important. So you might say, okay, the 2 important things are the price, which affects the second important thing, the number of customers they got. So if that's the case, you can take those 2 important things and you can use them as the highways on your roadmap, or you can use those 2 things as the variables in your model. So what you might do is you might plot the price against the quantity of lemonade cups that are sold. And you would say, okay, when the price was $1, there were 3 people who bought a cup. So I observed that coordinate. And then over here, I observed that when the price was $2 per cup, there was only 1 person who bought a cup, so I observed that coordinate. And then let's make an assumption. Let's say that the relationship between price and quantity follows this pattern. So you can just extrapolate based on what you've seen, and now you have a model or a roadmap, because what you can now do is you can figure out the path between price and quantity. In other words, one thing you did not observe was a table where lemonade was being sold for $1.50. You didn't see that. But with this model, you can figure out if that table was there, how many people would have been lined up behind it. So based on this model, if there had been a table where the price tag was $1.50 or $1.50, you should have expected 2 people to have gone to that table and bought lemonade. So this is why models are helpful. We can understand relationships, fundamental relationships, so that particular instances that we don't observe in the world, we can understand what would happen under those conditions. Okay, economists don't just draw pictures all day. So we want to take this model and we want to operationalize it and turn it into a formula. So the formula we're going to use here is the slope-intercept formula, which is of the form y equals mx plus b. And if you recall back to high school days, the y stands for the variable on the vertical axis, x stands for variable on the horizontal axis, the m stands for the slope, the b stands for the intercept. And first thing to recognize is that in this equation, there are 2 types of letters. There are letters that are variables, there are letters that are parameters. What's the difference? Okay, a variable is something that you want to be permitted to vary or to assume different values. So what are the variables here? Well, the reason we're writing out this whole model is because we want to figure out what would happen if the price changed in terms of how the quantity would change. So that means we want to allow P to vary, we want to allow Q to vary. So P and Q here are these two letters. So these are our variables. And then what's left over are things that are just perpetually true about the world. These are our parameters. So what's perpetually true is that the slope is always the same everywhere on this line. What's also perpetually true is that the intercept is always the same. Like, no matter how you look this graph, there's one constant intercept. So when you get done writing the whole model, what you need to end up with is an equation that has fixed numbers in for the parameters, or in other words, the things that are perpetually true. And then it keeps the kind of vague placeholders in for the variables that you can allow that thing to assume different values. So when you get done here, what you need is an equation that's of the form price equals a number times quantity plus a number, where this is the number for the slope, this is the number for the intercept. Okay, so I'm going to walk you through calculating this just so you can get spoon-fed once, and then for the exercise, I'm going to let you practice on your own. Okay, I'm going to kind of give you a step-by-step guide here. So the first thing to do when you're trying to actually get to the final destination of the box is you're going to take one observation and plug it into the formula. So we're going to plug in one thing you've, we'll say, seen. Okay, what's one thing you've seen? You've seen that when the price is 2, the quantity is 1. So this is one thing you've seen. You could equivalently put in that you've seen that when the price is 1, the quantity is 3. Okay, when you put that in, what you get is P2 equals MQ plus B. Okay, that's step 1. Step 2 is impute one thing you know. So here we know the slope, so here we're going to impute the slope. Okay, the slope is pretty easy to figure out because slope is just rise over run. So we've seen these two dots. What's the slope? Well, to get from here to here, you go up 1. You go over or back 2. So the slope is negative 1/2. So if you plug that in here, you get 2 equals negative 1/2 times 1 plus b. And then the third step is you solve for the unknown. Okay, here we're solving for b. This is the one unknown that we have in this equation. And you just take this negative 1/2, you move it to the other side, you get b equals 2.5. And then the last step is write out the equation with parameters filled in and variables, I'm going to say left open, so don't plug in specific numbers for the variables. Okay, so down here, let's just do this. So what we have is we want to leave the variables open, we want to plug in specific numbers for the parameters. So the final model here will look like price equals slope, which is negative 1/2, times quantity, this is a variable, plus 2.5. So this is the final thing. Okay, why is this helpful? This is helpful because we have an incredibly strong tool now that will tell us what would happen in different situations that we don't actually observe. For instance, if we wanted to know what would happen if kids started giving away lemonade for free, well, we could just plug in a 0 here, and that would tell us how many customers would line up. Maybe we have kids who have 5 cups of lemonade, so they want to get rid of exactly 5, and they need to figure out what price tag should I sell these lemonade cups at. Well, we could plug in a 5 here, and then we could figure out what the price would need to be to get rid of exactly 5 cups of lemonade. Okay, importantly, when you went out and you sat on the corner and you watched this, you never watched 5 cups being let go. You never watched a table that was giving away lemonade for free. But with this model, you can figure out what would happen in those situations that you didn't actually observe. So this is a primer on economic models. If you have any questions about this or math or anything that I've talked about, chat them out during the 10-minute question intermission, and then after that we're going to meet back and I'll let you practice some of this on your own. Hi everyone, it is now time to practice what you learned during class. I'm going to give you a scenario that's very similar to the scenario I gave you during the lecture, and then I want you to work through what I did for you during the lecture. So here's the scenario. You have decided to become an economist. You're going to go out, you're going to observe the world, you're going to figure out what's important, you're going to build a roadmap, and then you're going to make some assumptions, and then you'll have a really nice tool for understanding how the world works in their different scenarios. So specifically, here's the situation we've got. Suppose you observe two sets of kids selling puppies. Set of kids 1, set of kids 2. You notice that the first set of kids are selling their puppies for $150 a piece. The second set of kids, they're just giving their puppies away for free. And after watching them all day, you realize that in the first set of kids, they don't get rid of any puppies, so they've got the whole litter at the end of the day. In this set of kids who are giving their puppies away for free, they end up getting rid of 5 puppies. Okay, I'm going to do step 1 for you, and then you're going to finish up on step 2. Step 1 is you can look at this and observe and figure out what's important and then build a roadmap. Kind of 2 steps. Observe and build a roadmap. So I'm going to do both those steps for you. Okay, what you've observed is this. For the roadmap, you need to figure out what's important. What's probably important here is the price and the number of puppies they got rid of. And so the roadmap is going to include these 2 important things and then ignore everything else, including my bad artwork. So the roadmap is going to have price against quantity. You observed that when the price was $150, 0 puppies were sold. So quantity is 0, so you got 1 coordinate there. You also observed that when the price was free, or $0, there were 5 puppies, 1, 2, 3, 4, 5, that they got rid of. So you have another coordinate there. Okay, your assignment for the exercise is to write the equation, the formal equation, for this relationship. This relationship, as we'll talk about later, is called a demand curve, or once you extrapolate based on the 2 points, you get a demand curve. So you're really going to be driving a particular demand curve. So exercise is write the equation for the demand curve for puppies. Okay, there's going to be a particular thing that I'll be looking for the exercise. Again, I'm not grading exercise for accuracy, just completion, but if you do it accurately, this is what you need to do. So your final equation that you type into Blackboard needs to be of the form price equals a number, where you plug in here the slope of the line that you get after you do the extrapolation, times the quantity plus another number, where the number that you put in here is going to be the intercept here. Okay, just as a reminder of how you do this, the first thing you do is you take one of the things you've observed, one of the 2 points, and you temporarily plug it in here, temporarily. Then you take one of the parameters, either the m or the b, you figure out what its value is based on this, put it into the equation, and solve for the other parameter. Then you've got numbers for the slope and the intercept. Put back in the dummy placeholders for the price and quantity because we want to allow those to vary. Stick in the rigid parameters, and then have an equation of this form, and this is what you type into Blackboard. So that's the exercise. There's one to-do task for next class, and that is a reading assignment. So to do for next time is to read chapter 3 in the textbook, and that will help you hopefully understand what I'm talking about more next time I see you. So enjoy the rest of your day, and good luck on the exercise.